Okay, today we're going to look at providing all global energy with wind, water, and sunlight, empowering Charlottetown, PEI, Atlantic Canada, the US, and the world. Records in Atlantic Canada from September to December 2010 show that there were 3 new lows recorded at Environment Canada weather stations, and there were 86 new highs recorded at the weather stations across the region. 9 of the 10 hottest years globally have occurred in the last decade alone. This is 9 of the 10 hottest years in recorded history in the last decade. And so this is a severe problem and we need to act quickly to solve it. Because the Arctic sea ice extent is decreasing rapidly from the warming. We're uncovering the low albedo ocean below, and we're absorbing more heat instead of reflecting light back into space. And so as you do this, there's rapid positive feedback and warming problems get worse over time. And so if you look at the last 6 years, 5 of the lowest years on record occurred in the last 6 years, all since 2005. The lowest year was 2007. Linfin, China is the most polluted city in the world. It's the equivalent of smoking 3 packs a day. If you live in China, 16 of the 20 most polluted cities of the world are in China. And there's also pollution in many other parts of the world, and it causes 2.5 to 3 million air pollution deaths per year from energy use and pollution. So steps for determining solution to the problems: we want to rank energy technologies in terms of several impact categories and evaluate replacing 100% of the energy with the best technologies. And we want to consider resources, materials, matching supply, costs, and politics. Look at studying electricity and vehicle options. We want to look at wind, solar, geothermal, tidal, wave, hydro, nuclear, coal, carbon capture, and sequestration. For vehicle options, we want to look at those electricity options powering both battery electric vehicles and hydrogen fuel cell vehicles. We'll also look at corn or cellulosic ethanol E85 blends. So in terms of total CO2 equivalent of electricity sources, this is what it looks like. And you can see nuclear, there's a low estimate, which is from the industry, and there's a high estimate, which is the average of 102 peer-reviewed scientific studies. So you can take your pick. Weighted average ranking based on the several impact categories leads to wind, water, and sunlight being recommended. And so again, wind, water, and sun are recommended for powering battery electric vehicles or hydrogen fuel cell vehicles. And what's not recommended is nuclear, coal, carbon capture and sequestration, or biofuels. So to look at the recommended technologies, there's wind power, there's wind-driven wave power. These are wind turbines in Canada. This is a West Cape wind farm on Prince Edward Island. This is a Pelamis wave energy converter in a test site in Europe, and there's plans for arrays of those. There's also hydroelectric, geothermal, and tidal power. So that's an illustration of the geothermal potential from the Banff Hot Springs in Alberta. And so you can basically consider that water power, because you're using water heated within the Earth's crust to generate steam, which is used to power a turbine and generate electricity. And so that's a geothermal plant. That's a 10 megawatt plant in California. And that's the largest tidal turbine in the world. It's going to be deployed in the Bay of Fundy by Irving and Lockheed Martin. Concentrated solar power and solar PV power. So basically using the sunlight and focusing it on a tower to heat molten salt. You can provide baseload power when the sun isn't even shining, because molten salt is heated. You can put water next to the molten salt, and that turns into steam, which drives a turbine and generates electricity. The largest PV site in Canada was actually, in 2007, it was actually the Jean Canfield building array in Charlottetown. Now it's in Sarnia. It's 870 times larger than 3 years earlier. It's the largest solar photovoltaic facility in the world. It's because of a feed-in tariff, and that's what we need in Canada. Electric and hydrogen fuel cell vehicles, you can do cars, you can do pickup trucks, you can do a number of heavy-duty trucks, you can do aerial lift, or you could do refrigeration, flatbed, military, delivery trucks, you name it. You can do electric or hydrogen fuel cell buses. All of these things exist. You do even small electric aircraft exists today. Electric bikes or electric scooters, great way to get around in the warm season. The wind powering battery electric vehicles, well, right now we have about 80,000 vehicles, and the West Cape Wind Farm would power them all on PEI. And this photo is a fraction of that wind farm, and it's enough from this photo to power 50,000 vehicles with wind. The area to power 100% of PEI's personal vehicles, comparing wind, battery electric vehicle, that's a footprint compared to sugar beets, which are being proposed, or corn or cellulosic E85. You can't even draw a circle on PEI without touching water. Inside a softball field, and that's the amount of area of tubes touching the ground for wind power personal vehicles on PEI. So the distance to refuel stations is how you build an initial backbone of coverage so that you can use fast chargers when you're charging at home. That's what you do most of the time, or at work or in public places. But when you're on the run, you need a fast charger for convenience to avoid range anxiety. That's how you would do it, and it wouldn't cost very much to build this initial backbone. So you could do electric trains, hydrogen fuel cell ships. That's a passenger ship in the bottom left that exists, 100-passenger ship. It's an electric ship in the Navy that exists, and a PI manufactured hybrid tug that I put there just out of interest. And liquid hydrogen aircraft, well, we don't have that today. It's probably about 10 years away in terms of ground and flight testing, but we would have to start to try to commercialize it. But we could do it. We've already got liquid hydrogen space shuttles, so in terms of other aspects of this overall energy system, there are air or ground source heat pumps, which will reduce your heat demand by a factor of 2 or 3. And there's also solar water preheaters that can provide, 40% of your total water heating needs, for instance. Or you could use a community-wide array of those and actually store the heat in the ground all summer long, charging the ground up, and then call on that heat like this community does. It provides 90% of space heating from solar water heaters. It costs $700 a year to heat, and you can just build communities like that. That's in northern Alberta, and that's a net zero energy home that exists in New Brunswick, and it's just an example of space heating using wind storage options. Ceramic bricks. You can basically take out oil furnaces, put in ceramic bricks, and then use that as a thermal mass. Because the wind is doubly as powerful in the winter, you can use that excess and heat reliably. Powering the world on renewables, you decrease the future demand by 30% because you're switching from the current fuels and you're avoiding internal combustion engines. You're using battery electric vehicles, which are 5 times more efficient. You reduce the overall future power demand. Just looking at wind and solar from an energy resource point of view, you can power the world 6 to 15 times over with wind on land or near land in windy locations. For solar, you can power 30 times over on land in sunny locations. And so it's really about how to combine these. So in terms of combining these optimally, here's the number of plans or devices to power the world. This is a plan that is published in peer-reviewed scientific journal, the Energy Policy Journal, in 2011. It's 50% wind, 40% solar, 10% everything else. So 3.8 million 5-megawatt wind turbines is enough to power half of the world. So I looked at wind turbines, blade, turbine and tower factories and jobs to power half of the U.S. Submitted these comments before the U.S. Department of State on the Keystone XL pipeline versus the idea of sustainable energy in Canada, U.S., and world. I looked at doing this for Canada, so I looked at wind speeds seasonally. I looked at solar insolation, which changes seasonally, and this is the seasonality. This is monthly wind compared to monthly PV output in PEI. So you can see that the wind is more in the winter it peaks, and then the solar tapers off in the summer, and that's a mainly sunny day at the Gene Canfield building in late September. So in the midday peak power demand, you're actually pretty much providing full capacity for the 100 or so kilowatt rooftop PV system. You're providing over 75 kilowatts for 3 hours of the day when the demand is highest. Canada geothermal resource, there's basically the equivalent of 20 large nuclear power plants that could be providing geothermal power. That's different than heat pumps, which reduce power demand again. So the tidal power resource, again, there's lots of it, tons of it in the north, but anyway, in the Bay of Fundy there's lots too, and we can predict this hundreds of years out into the future. Canada wave power resource, it's 4 to 7 times more in the winter compared to the summer, and there's lots of it on the Atlantic or the Pacific coasts. This is Canada hydroelectric, and these are the large reservoirs highlighted in red. And so combining these, I looked at providing half all energy in Canada with wind, 55,000 large 5 megawatt wind turbines that provide half all energy. So then basically 25% hydro and 25% everything else. That's evidence before the Parliament of Canada's Senate Committee on Energy, the Environment and Natural Resources that was submitted at a public hearing in March by myself. In terms of the number of plants or devices to power the Atlantic region, so I've looked at that too. There's enough resources. I don't know how to combine them optimally yet, but that's the next step. From that study, basically the greens on land, that's total spacing for all the wind to provide just under half of all energy in Atlantic Canada. And that's just under half of all PEI's land area. But the actual footprint of the tubes touching the ground, that's 90% of the area of Parliament Hill. The rest can be used for agriculture, open space. The water is 832 times more dense than the atmosphere, and so the total spacing required for tidal, for 9% tidal for all energy in Atlantic Canada, is a speck on this map in the Bay of Fundy. So it's really not that difficult to imagine how this plan would be rolled out. And so the next step is really looking at how to optimize. So this is an example of least cost optimization for California, so that you can basically bundle the WWS resources and provide all hours of the year carbon free. And this study doesn't actually include some of the different ways that you can address variability. But whenever you do include those things, you're basically going to be able to provide all carbon-free power all the time and not even need to have any carbon-based backup on hand. And so I've described all the options under the sun briefly, including the moon as seen here, which creates tides. And I think we can power the world.